Hello students and welcome to this calculus lesson. In this video, we're going to go over 4 examples using the fundamental theorem of calculus, and then I'm going to show you guys how you can actually use your calculator to check these results. So let's get started. So here in our first problem, we're going to tackle it again using the fundamental theorem of calculus. So we're going to need to find our antiderivative. So if I'm doing this, I'm going to find, okay, so that's going to be x squared minus x cubed over 3, and we're going to evaluate this from -1 to 2. So let's go ahead and do our upper bound minus our lower bound. So that's going to be 2 squared minus 2 cubed over 3 minus, this can be -1 squared minus -1 cubed over 3. All right, so that's going to get me 4 minus 8/3 minus, let's see, that's going to be 1 minus, so plus 1/3. So let's go ahead and simplify this. So I'm going to get 4 minus 8/3 minus 1 minus 1/3. All right, so 4 minus 1, that's going to get me 3, and -8/3 minus 1/3. So -8 minus 1 is -9. So I get -9 over 3, which gets me -3. So 3 minus 3 is going to get me 0. So this result comes out to be 0. And like I said, I'm going to show you how to actually find that on your calculator. So I have my calculator here, and this is the way that I like to do it. So I'm going to try to, we're going to make a new document. No, don't save that. And we're going to add a graph. What I want us to do is I'm going to put in our function 2x minus x squared. So go ahead and graph that, and we get our function when we can see that it is a parabola. So what I want to do is I want to find the integral. Just like we are finding the derivative, we're going to go menu, analyze graph, and you see here that we do have integral now. So of course we can click and drag and stuff, but I'm just going to type in -1 for my lower boundary, and I'm going to go over to +2 for my upper boundary. And you can see that these are the areas that are bound here by the x-axis. And the result comes out, of course, sometimes you do get these wonky numbers, e to the -14, that is going to be a very tiny number, which can get rounded off to 0. So you can see sometimes it does take some interpretation of our calculator, but we do see that the results are equivalent. So let's go ahead and look at our second problem now. So of course, we're going to start with the antiderivative. Let me kind of rewrite this real quick. So this is going to be from -2 to 3 over, x to the -2nd plus x dx. And let's see, that's going to be, we're going to add 1. So x to the -1 over -1 plus x squared over 2. And we're going to evaluate this here from -2 to 3. All right, so let's go ahead and do that. So I have -1, I'm just going to rewrite it real quick. -1 over x plus x squared over 2. And now I want to substitute in my values. So I'm going to get -1 over 3 plus 3 squared over 2 minus, we're going to get a -1 over -2 plus -2 squared over 2. All right, so let's go ahead and evaluate this. I get -1/3 over 9/2, or sorry, -1/3 plus 9/2 minus 1/2 plus 4/2, which is 2. So I'm going to distribute that negative now. I'm going to get -1/3 plus 9/2 minus 1/2 minus 2. So I do see that these 9/2 minus 1/2, that's going to give me 8/2, which is 4. 4 minus 2 is 2. So I get -1/3 plus 2. And 2 is 6/3. So -1 plus 6 is going to get me 5/3. So let's go ahead and check this on the calculator now. So we're going to go and we're going to add in a new document again. Say no. We're going to add graph. All right. And I'm going to put in my function 1 over. All right, so there's our function. We're going to do it the exact same way. We're going to analyze graph, and we're going to go integral, and we're going from -2 to 3. And again, we do have to do some interpretation here. And what I notice first and foremost is that this is a very large number, e to the 10th scientific notation, an extremely large number. And the reason for that I want you to notice is that here we do have a function that is not continuous at 0. And you need to go back and you need to read our work. The initial definition of the fundamental theorem of calculus states that a function needs to be both continuous and differentiable on the interval that you're going to try to find. So I cannot go from -2 to 3 because the function is not defined at 0. So we've done all this work, and you do still need to check this out because this does not exist. We cannot calculate the area between the curve and that is bounded by the x-axis because we have an infinite area right there in the middle. So keep in mind, since this function is not defined when x is 0, that's why we can't do it. And we could have saved ourselves a lot of time by noticing that from the beginning. Then we'd be able to say it does not exist, as opposed to going through all the work, spending all this time doing all this arithmetic in the end to find 5/3. So let's go ahead and do these last two problems. See if you can get the exact same answers as me. All right, and those are going to be our two answers. So our first one, we get 2 log 4 plus 9/4. And then our fourth one is going to be equal to pi squared. So there's the work for that. If you're not getting any of these answers, or if you're still confused, you might need to go review antiderivatives from 6.1. But of course, if you notice something that's incorrect, or if you need help on something, you can always reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.